So we know that generative AI can output some really good models, and this will be the case study where we're also going to analyze the output mesh from Spark 3D. So this is the reference image. We see over here a wooden rooster. This will be the output 3D model. And as you can see over here directly within the viewport, the model has quite a lot of details. But now let's see if the mesh has any self-intersection and any additional problems. So to do that, I initially loaded the model within Blender. And we're going to see that within Blender, the model will look like this. We see over here some weird shapes regarding the filling of the bottom side. If I'm going to check over here for cavity, we're going to see that those will be visible. Now, in order to see if the mesh has any self-intersections, I'm going to use GeoMagick in this case. So we have the Rooster model loaded over here. And if I will enable the mesh doctor, we're going to have the possibility to analyze the mesh and see for various elements such as non-manifold edges. We're going to set in this case there will be 0. But we do have a high amount of self-intersection, so I'm going to go ahead between all of those. So we see over here the total triangles that have self-intersections will be over here. And they will be highlighted within the viewport with red. So we see that there are many areas, but most importantly over here on the bottom side, we're going to have many self-intersections. So I'm going to have those processed and applied, and we're going to see that those have been fixed. I can now also analyze the mesh for highly creased edges, and we again are going to see a lot of those on the bottom side of this rooster. I can go ahead and have those also processed by mesh doctor, and those highly creased edges should now be addressed. It takes a little bit of time to have those processed depending on the 3D model, and in this case we're going to see that the total triangle count for this wooden rooster is 2 million. So quite a lot of details for a model generated using a single image input. And based on the specification of your computer, this may take up to several minutes in order to have those highly creased edges processed. While this is being processed, I'm going to jump within Blender to better analyze the mesh. If I'm going to press Tab, we're going to see that in this case, this will be a triangulated mesh. So similar to the ones that we obtain using 3D scanning. If I'm going to shade this, we're going to see that those will be fixed by the shader, so visually. But still keep in mind that the mesh will have those problems. Now, within GeoMagick, this is still processing, and as you can see, the highly creased edges takes a little bit of time. I'm also intrigued by the amount of detail over here on the rooster leg over here, as you can see. So while that is being processed, I'm going to jump over here. Now, we see over here that this is not into detail, so the rooster should have additional elements over here. But if you're going to check this ornament from a distance, something like this, it's more than, let's say, sufficient in details. And this can always be done in post-processing. Now we have those highly creased processed. There are still 12. And those will be still located on the bottom side, so I'm going to process those as well. With Mesh Doctor, you can process the whole mesh, but within this video, I want to highlight each individual analysis and operation that can be done within Mesh Doctor. And this is something that generative AI models require, but it's the same for 3D scanning, because 3D scanning will also obtain a lot of additional details that will have to be fixed. There are still 8, so in this case, we need to reapply the same highly creased edge analysis and apply it multiple times until we're going to see that the total number will go to 0 over here. So it's not a specific number of steps. Maybe for some models there will be required like 3 or 4, for others maybe 10 or 20. So it highly depends on the model. We see over here that those highly creased edges, in this case those 8, even if in some cases those will be processed, for example the one that was over here previously highlighted with red on the bottom side of the model, maybe within some other areas of the model some highly creased edges will reappear. So with each, let's say, remeshing using the mesh doctor, those will cannot reappear. So we still have 8, but I'm going to leave that. I'm going to enable spikes, and we're going to see that spikes will be a heavy amount. We see that the selected number of triangles, so close to half of the triangles will be considered as spikes. So I'm going to have those processed. Keep in mind that during this process, the mesh will change, so the deviation. But considering that this was obtained using a generative AI, we don't really have a model as a reference to compare this. This way 3D scanning is a lot better because that will try to replicate the object real features and have those digitally obtained. We see that for spikes there are still few, but I'm going to leave that. We're going to have now small components, 180 in this case. We're going to see that those will not be highlighted directly on the mesh, but I'm going to have those processed. Still, I'm really impressed that the amount of features that this generative AI model has. It does require a lot of smoothing. Over here as well, we see on the Rooster head. We can do that in Blender within the sculpting environment. So if you are just into open software, you can use Blender, and as we can see, we can have this smoothed. But it does take a little bit of time, and using GeoMagick, you can rapidly apply those elements, because we have over here remove spikes. We also have quick smoothing that will be applied to the whole model, and we're gonna see at the end of this video how we can apply that. We see that especially over here on the top face of the wooden ornament, it will require a lot of smoothing. Now I'm just gonna update all of those, and I will have all of those processed. If you are into, let's say, creating step files for computer-aided design, it is really important that you're going to fix all of those within the mesh doctor, so that when you're going to take the model maybe to CATIA or other software, you can have that processed and you can define a closed body. That means you will have material on the inside, so you can then easily use that within various applications. So we still have some small spikes. I'm going to hit apply. And even if Mesh Doctor will still have some of those spikes, I will go ahead and have this smooth. And you're going to see how that those small details over here will be fixed by that. Okay, we still have some highly creased, but I'm going to leave it like this. I'm going to move closer over here to the Rooster. Okay, and we're going to do a quick smooth for the model. So this will be applied on everything. And we see with that quick smooth how those will look a lot better now. We can have it reapplied. In this case, for quick smooth, we don't have the possibility to adjust some parameters, but we can also remove spikes. And over here, we have a slider. We can also use relax. You see over here that smoothing level, how it smoothened out everything, but at the same time, the model will be a little bit smaller because that will also decrease that. We can also change over here the strength, the curvature priority, and again, we can have that applied. This will also give us some deviation statistics and tolerance. And at the end, our mesh will look like this. So, in my opinion, this is a great model. So, considering that this was a single image, it's quite impressive. And this is something that wasn't even considered to be possible a few years ago. Now with Mesh Doctor, we can go ahead and we can have this process. And again, it's quite important if you want to take your model to a CAD solution that this will not have any problems. So you should have this applied several times until the spikes, they can be processed within computer-aided design, for example, within CATIA. Okay, so now we see that everything is set to 0. Now that model is ready for to be transferred to a CAD solution, and over there we can go ahead and maybe we want for this wooden ornament to have a manufacturing program. It does have a lot of details over here, so it will require multiple axes, but that can be done. Okay, so I hope you enjoyed this kind of content. I will position a similar video on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.